And now I'm going to introduce a brief video from one of our main sponsors, which is Sandvik. I think the video is ready to go, but I just want to sort of set it up here. And this is Sandvik's next generation of autonomous drilling. So less than 2 years after introducing the AutoMine concept loader, which was the first fully autonomous underground mining machine built specifically for automation, Sandvik has now expanded its vision from autonomous mucking to autonomous drilling with its AutoMine concept underground drilling. Unveiled and demonstrated for the first time at a customer event at the Sandvik Mining and Rock Solutions test mine in Tampere, Finland, just 2 weeks ago. So the AutoMine concept drill is fully autonomous, twin boom development drill rig capable of drilling without human interaction. This cabinless battery electric drill can plan and execute the entire drilling cycle from tramming to the face, setting up for drilling, drilling the pattern, and returning home to charge for the next cycle. So we are ready to run this video. I have seen it. It is pretty spectacular, and most Sandvik videos are pretty spectacular. So sit back and enjoy, and I will take myself off screen. Okay, excellent. Thank you very much. So now I'm going to a really wild video. You got to admit, it's impressive to watch. The music, great. I think I got caught tapping to the beat and I wasn't on mute there. But I'm now pleased to introduce Jean-Pierre Desmarais, who is he joined Sandvik in January of 2021 as the sales manager for automation in Canada after 3 years at Nutrax, which is one of the new Sandvik companies. He graduated from École Technologie Supérieure in mechanical engineer. Jean-Pierre has always worked with high technology. Now as a digital application specialist and interim business line manager, automation, he will be working as a business leader and digital consultant both internally and externally across the various Sandvik business units. And now I am going to turn it over to Jean-Pierre. And thank you very much for taking the time out to be here with us. I know it was a little bit last minute, but I will turn it over to you and you can proceed.
Thank you so much. I hope everyone can hear me well. Thanks for having me. It's a pleasure to be presenting to you guys today on behalf of Sandvik. we wanted to start this conversation with this presentation with a bit of a technology video to where we're at. I think, just for myself and for the general public, it's important to know the commitment that Sandvik has toward the investments in technology for mining. Amelia is certainly a big step forward for us in testing new technologies and bringing that forward to the mining industry. And we are committed by doing these concept vehicles. We started 3 years ago with the concept loader, which was cabinless and used 3D LiDAR technology. We were able to test some of the technology, the early technologies that we're going to put in our equipment moving forward. So I think these concept vehicles are the testament to our investment in technology. What I want to cover today is a bit of an overview of what an automation system is about, where we're going with it, and what's our vision, and what you guys can expect from us in the future. So what are the components that you need to do efficient automation operations, especially underground, but in surface is similar. So you'd need the first component would be the control room, where you need to be able to access the machine and be able to communicate with the machine and able to drive the machine. So you need the control system. We have 3 types of control system. One is a specific chair. We have a pedestal stand that could either sit on surface or even close to the area where the equipment is to work, or a desktop control system that you can see. There's the equipment component. So this is an example of a loader, but it would be the same type of equipment that you would see on a truck, for example, on a surface drill, or even an underground drill. We retrofit our equipments with cameras, LiDARs, scanners, computers to be able to control the equipment from either surface or away from the equipment itself, so it's drivable. To give you an example, for Sandvik equipment to be able to be automated, we're looking at anything past 2015. The control system prior to 2015 is usually a bit too old to be able to be remotely operated from the distance. The line of sight mode still applies, but for complete autonomous operations, we typically require a 2015 and younger machine to be able to be automated. But in the production environment, usually these machines get replaced in that type of time frame. So we usually find that type of machine. And then in the underground component, the current technology doesn't allow us to unleash the machines into the work areas where you have manual equipment and also pedestrians walking around. So we have a high safety standard, and we need to isolate these machines to make sure there's no collision between an auto-mine vehicle and a pedestrian or a light vehicle that's parked. So there is a need for a physical person to come in the area to clear, to make sure that there is no obstruction in the work area, that's deemed safe to operate in automation, and then we can resume automated operations. We use 2 different types of barriers. We use 2 barriers. The main reason, one is on the manual side and one is on the automate side. The reason being is if the equipment is to malfunction, it needs times to stop between the light curtain before it hits the other one. And then the same thing from the manual side. So we calculate the distance between the light curtain on the speed of the maximum speed the machine can reach, the actual decline. So based on that calculation, it's a simple calculation, but we make sure we have a safe distance that any type of circumstances, the equipment will have time to stop between the 2 light curtains. So what does this automation system require? We're very demanding on network infrastructure underground, because we have standard for bandwidth and latency that are pretty high, especially for video. Usually the biggest demand on bandwidth for underground mines is on automation. The 2 major trends we're seeing across Canada and in the industry is LT and Wi-Fi. From my personal experience, what I see is a lot of legacy sites that already have Wi-Fi infrastructure will continue down that path of Wi-Fi. Usually the newer projects or the newer phase of mining will move into an LTE solution. For us, we are network agnostic, so it is important to know that we can connect to a Wi-Fi network, LTE network, or even a 5G network. We just need an external client that is sufficient and then connect to any type of even service provider. We've worked with Nokia, we work with Ericsson, Ambra, different types of providers, which is fine for us. We are network agnostic. One of the advantages that we see with LTE is there is far few less handovers between access points. The access points needs to be, there's not as many access points going underground. So when we struggle with some of the coverage underground for Wi-Fi is during that transition from access point to access point, sometimes we lose communication and then we lose the machine, because in the automation system, the importance is the continued communication. If you do lose communication, the machine will revert back to the safest situation and go to an e-stop, and you have to reconnect to the machine, which is possible, but communication loss will revert back into its safest position and go into an e-stop. So the LTE has been proven to be very reliable, although a lot of machines are run right now under Wi-Fi. So what are we doing today with the Sandvik Canada in automation? I just here. As you can see, there's quite a few different ways to run an automation system. There's a teleremote way, there's an assisted teleremote, there's auto cycle with manual activation, and there's fully automated. So some of the operations are being done teleremotely assisted. Some of them are completely automated. One thing that is important to mention is a robot is very good at repeating the same tasks over and over again. A lot of people ask us if it's possible to run a full automated cycle in a stoping application. It is possible, but it's a bit difficult for, or even a dumping into a truck operation. We usually recommend for people to run that in teleremote, because in a case of a stoping application, for example, it's very important for the bucket fill to be quite consistent, and the loader itself is not good at aligning itself where it needs to be in the muck pile. If you look at a block cave application, it's quite well, because the drawbell will always bring the material in the same spot. So the loader can come in and actually just pick up the material quite easily and have the bucket fill be efficient without any operator intervention. The same thing in the dumping. If you dump into a truck, the distribution across the truck is very important. So a manual input and where the material sits based on fragmentation and so forth is quite important. So in a truck loading application, we do recommend having typically a teleremote operator coming in with some assistance of the equipment, but still manually teleremotely operated. But if you look at an ore pass or crusher, it's very easy to have an automated equipment coming and dumping into an ore pass or crusher. They'll do that repetitively, very successfully. So some of the approach that we have is usually the entry to automation is local safety zones, where single machines or multiple machine will operate either on a level or in a ramp. So it's an isolated zone that can work between the shifts, or even during the shift. If it's on a level, for example, you can subdivide some of the zones, but that's really where people start, is between the shift, doing usually it's muck to remuck application, and then maybe loading some trucks during the shift from an isolated zone. But since some of the earlier applications that we see, Glencore Kid Creek is one of the applications that we have. They have multiple loaders running with multiple chairs from a single control room. They are quite successful, and some of the numbers that we see here is on the multi-machine system has been quite successful in increasing 30% of effective production hours compared to conventional loaders. So we are tapping into unused hours of operations that typically weren't tapped in before automation was available. Then we could look at some hybrid models. We are using a lot of dynamic zones at the moment. So you could subdivide the level into multiple smaller zones, depending if you need to access a drill, for example, if you need some work to be done. We are able to merge and split zones as manual equipment needs to travel in certain areas. You can see from 1 to 6 here, where an automated truck would wait for a zone to be automated. And then once the manual person or the manual equipment has cleared the zone, it becomes automated. So we're able to dynamically move from an automated situation to a manual situation. But the equipment itself always needs to be isolated from any pedestrian or automated equipment. Hikla Berardi does have a transfer level that they use, and they're quite successful. You know, it's a closed off area, so they have the chute and they have a dumping area. So they have the operator manually operating the chute, filling the truck, and then it goes to a dumping area. And then the next level for us is really the full mine automation. We call it fleet automation. So it brings in the next level where we have traffic logic, interaction between different types of equipment. So manual, so loaders and trucks can interact one another, different equipment types. Some of the drillings we're integrating, I'll touch that in a bit, but it's really having a priority of equipment. I'd say there's a loaded truck kind of coming up the ramp, and there's another truck coming down the ramp, which is empty. So the truck that's coming down the ramp would know somebody's coming up the ramp with a truck with coming automated, and then would go to a passing bay and let the loaded truck. So there is a prioritization, and there's even a queue handling where, let's say there's 2 loaders coming into an ore pass, and then you would queue one of the loaders first, and then the priority loader would come in the ore pass and dump its muck into the ore pass first, and then wait for the one that's queued up would wait for the first loader to get out of the way and go back to the muck pile before it goes into the ore pass and dumps. So in that case, we can go up to having just a gated surface, and the whole mine becomes an isolated zone, and then we can run multitudes of equipment together into that zone. LZ5s in that case, they run 4 LHDs and 4 trucks between the shifts, and also on weekend evening shifts. The numbers are pretty impressive of what they're able to do there. They're up to about 20% of their monthly material move with an automation system. So in their case, automation is not an addition, it's something that they expect the mine to produce with. So that 20% is not on top of their monthly targets, it's part of their monthly targets. So what are the next steps for the automation systems? So what we're going to do, and you saw it in a bit in the Amelia, is we're going to go from a 2D navigation system, which uses a slice of a map, into a 3D system to be able to detect spillage. As you can see in a 2D plane, if there's a big rock or a spillage or a rock fall or even a light vehicle, the scanners won't detect them. It's going to run over it, and then it has to be taken over from the operator. In automation, it won't see what's happening in front of it. In a 3D environment, then you're always comparing yourself to the mapping, and then you can see if there's variance from the map. And we are at that point where we're going to start doing a lot of 3D mapping using 3D LiDARs on light vehicles instead of using production equipment to do the mapping, and then slicing that into a 2D environment, and even using 3D LiDARs for navigation, like we did for Amelia, where she would position herself in the drift on her own, and then level herself into the right position. So 3D navigation is the way to go, and it's coming in the next short while. The other aspect that we're working on is really interoperability. As most of you know, probably in automation systems right now, the load and haul sits on one side, the drilling automation sits on the other, and then all the auxiliary system, the auxiliary equipment sits outside of any OEM equipment. So we are working on providing more interoperability between equipment providers, and also between our own equipment, to integrate drills into the system, to make sure that, let's say there was a loader, it would know that the drill is there performing its work, so it won't enter a space So interoperability is quite a topic at hand, top of list for us right now for 2023 in automation. So what's missing for a fully automated mine? Certainly for us at Sandvik, we are acquiring a lot of technology companies. You saw us acquire Sandvik, and it goes back a bit to, sorry for jumping backwards, but to the interoperability. We want to be part of the whole mine plan, from the early design of the mine with Sandvik SCED and all the way to the operations management into Sandvik Ops. And then to the operations into to automation and so forth. So we want to be part of that full mining cycle. And the other company we purchased is Nutrax, which is developing a collision avoidance system. And for us, that's really the next step for the automation system to be unleashed in through manual people and machines. So I have 2 quick videos I want to show you about where this is going.
The underground environment is full of hazards. We all have the responsibility of managing the risks associated with these hazards. In doing so, we can all work in a safe way and return home safely. Luckily, we have technology to help us manage these risks. The new CAS system can save the lives of your fellow workers, and maybe even yours. Look, this is the new equipment I have been given. It tells me where all the hazards are around the machine, through this multifunctional display. It observes around the machine and warns me timelessly if there are people or other equipment in close proximity, even if I can't see them. It even tells me how far they are from my machine. Clever. It also shows me in which direction my machine is moving. Ah, here we are. See, there's another LHD standing there. Now watch the screen as I get closer. See how the screen tells me there is a vehicle. It shows me where the vehicle is. When I get closer, it will even tell me how far away the vehicle is. The lights and indication on the screen are still green. It warns me that there is something close by me and that I must be on alert.
Slow down.
As we get closer to each other, we need to be more careful. Did you notice the green light is now yellow? That means the machine is moving closer and is now in the alarm zone, which means we all must slow down. I have slowed down, but the machines are still coming closer to each other. The red flashing light and red indicator on the screen tells me I am now in the danger zone. I must stop.
So I do have another video for pedestrians, but it just uses a lamp instead of the interaction between the 2 vehicles. One of the points I wanted to mention is it's quite important for us to have, we see a lot of screens in the trucks and LHDs, and we decided to go down the path where we have a visual outline on the vehicle. Those pucks on the outside of the vehicles not only include the sensors, but also include the visual light that would display the most imminent threat to a vehicle. So an LHD operator can know if somebody or a threat is coming, because as you know, it could be slowly approaching an LHD that's parked, but there's another vehicle that can come on the side, and then that becomes the most imminent threat because the one that's on a bit further away is parked and not moving. So the visual inputs on the outside where the LHD or the truck operator would see is displaying the most imminent threat at that moment. So for us, it's very exciting to be, thinking that in the near future, and, again, the big question is, when is that coming in, that level 9, stopping the vehicle, the slow to stop and unleashing the robots, like my ex-boss would say. We're really thinking around 2025, 2026 because of the legislative changes that need to happen in the mining industry to be able to make a system functionally safe and make sure that all the test scenarios have been covered before we unleash the robots. I think that does cover my time. I don't want to get too much in detail. I see there's a couple questions. I hope that was interesting, and I didn't. Oh, I apologize. I hope I didn't run over my time here.
That's okay. We're very pleased that you got a lot of information that was very useful. We do have a couple of quick questions from the audience. I do want to read them and see if you can give the answers.
My pleasure.
Okay. The first one is for the remote control technology and autonomous mucking, are you using an in-house or third-party software? I think
it's in-house.
It's in-house. Yeah, I was going to say you guys tend to buy the software companies you like to work with.
Yeah, we do.
Sandvik, yeah. And then I had another sort of a longer one. It might even be a business opportunity too. From somebody who works for Doppelmayr Canada, and they produce an aerial conveyor, and they think their control and command interface would possibly be an easy integration into your full mine automation system. And so does Sandvik consider at this time to integrate on the automation system equipment from other producers?
Certainly, I touched on it in my presentation through the interoperability slide. We'd like for mines to use 100% Sandvik all the time, but the reality is just not there. So we have to be cognizant of that reality, and we want to be more interoperable and have an open architecture with other OEMs.
Excellent. Thank you very, very much for your time, JP. And I think we are ready to move on to the next presentation.
Thank you so much, everyone, for being there and listening to my presentation. I'm always happy to connect if you have any questions.
Yes, any questions, we can still answer them offline if you want to send them to them, because I know there's a lot of detail in there. And like Sandvik has more than just automation too. So this may lead you to a lot of other questions about some of their other services and equipment that they do offer.
Yeah.
Perfect. Thank you very much, JP.
Thank you.